Near the end of the dinosaur age, long after most giants had already come and gone, the world produced something unusual. Earth had been experimenting with size, shape, and survival. For more than 160 million years, entire dynasties of dinosaurs had risen, ruled, and quietly disappeared. And in this late, fragile chapter of Earth's long history, a final predator emerged. Not as a beginning, not as a symbol of growth, but as something that shouldn't have been possible. An animal built wrong, a design that broke the rules, a predator that evolution never intended to create. It was not shaped by a stable planet, it was forged by a world nearing its end. Only then do we give it a name, Tyrannosaurus Rex. This episode is supported by Planet Wild. We'll return to them later in the story. Before we can meet Tyrannosaurus Rex, we have to answer a more basic question. How do we even know dinosaurs existed at all? Because no living human has ever seen one breathe, walk, or hunt. See, everything we know begins with stone. When the first dinosaur fossils were uncovered in the early 19th century, they were fragments, teeth, bits of bone, shapes without context. Early scientists did their best to imagine the animals that once carried them. The results were strange. Dinosaurs were drawn like oversized lizards, dragging their tails, sprawled low to the ground, slow and dim-witted. They were monsters, not animals. And obviously, those early images weren't foolish, they were honest. They reflected the limits of the evidence at the time. As decades passed, fossils accumulated. Skeletons became more complete. Trackways revealed movement. Bone structure hinted at posture, muscle, speed, even metabolism. Each new discovery forced us to redraw these animals, not once, but again and again. Today, paleontology is one of the most data-rich historical sciences we have. More than 10,000 dinosaur fossils have been discovered. Over 900 distinct species have been identified so far, and the story is still growing. Between 2003 and 2022, scientists identified, on average, about 45 new dinosaur species every single year. That's not because dinosaurs are suddenly appearing. It's because the Earth is still giving up its secrets, slowly, reluctantly, layer by layer. With every new fossil, our picture of the dinosaur world becomes sharper and more surprising. You might think, why are we discussing these? To truly understand T-Rex, we have to travel far deeper than its bones. We have to go back to the beginning. Long before the continents looked the way they do today, the Earth was united into a single vast landmass, Pangaea, a world without oceans between continents, a world of extremes, vast deserts inland, seasonal monsoons near the coasts, and violent volcanic activity reshaping the planet from within. The oldest dinosaur fossils appeared toward the end of the Triassic period, around 230 million years ago. These were not giants. They were small, lightly built, often overshadowed by other reptiles that ruled the land at the time. The Triassic Earth was hot, dry, and unstable. Mass extinctions had recently cleared ecological space, and evolution was experimenting rapidly. Early dinosaurs were just one of many contenders trying to survive in a dangerous world. Then, around 201 million years ago, the Earth changed again. Volcanic eruptions tore through what is now the Atlantic region. The climate shifted. Many dominant reptiles disappeared, and dinosaurs, almost by accident, found themselves inheriting the planet. This marked the beginning of the Jurassic period. The Jurassic world was greener, wetter, and warmer. Vast forests spread across the continents. Dinosaurs grew larger, more specialized, more confident. Some evolved into colossal plant eaters, others into formidable predators. Thanks largely to cinema, this is the era most people think of when they hear the word dinosaur. The Jurassic period became famous not through fossils alone, but through film. Jurassic Park etched it into popular imagination so deeply that it now feels like the definitive dinosaur age. But here's the truth. The Jurassic was impressive. It was not the peak. That came later. The real explosion, the age when dinosaurs truly flourished in diversity, size, and ecological dominance, was the Cretaceous period. Beginning around 145 million years ago, the Cretaceous was the longest chapter in dinosaur history. The supercontinents Laurasia and Gondwanaland began to fragment, slowly drifting toward the arrangement we recognize today. New coastlines formed. Shallow seas flooded inland regions. The planet grew warmer, sea levels rose, and life responded.
Flowering plants appeared and spread, transforming ecosystems from the ground up. Insects diversified alongside them. Herbivorous dinosaurs adapted to new food sources, and predators followed. Almost every type of dinosaur you can imagine lived during the Cretaceous. Swift, intelligent raptors, heavily armored giants, long-necked titans that shook the ground with every step. Some of the largest land animals to ever exist. Argentinosaurus, weighing as much as 77 tons. Tyrannosaurs, stretching longer than a blue whale laid end to end. And among them, near the very end of this long, crowded era, appeared something extraordinary: Tyrannosaurus Rex. Despite its fame, T-Rex was a late arrival. It lived only during the final stretch of the Cretaceous, roughly 68 to 65 million years ago. Its reign was brief, geologically speaking, but intense. Most scientists agree that T-Rex did not exist during the Jurassic period at all, which makes one detail quietly ironic. The animal chosen as the logo of Jurassic Park didn't live in the Jurassic. This isn't a small mistake. It reflects a much deeper problem. Every dinosaur film we've ever seen collapses time, not by thousands of years, but by tens of millions. Species separated by vast stretches of deep time are shown living together, hunting together, dying together. Entire evolutionary eras are blended into a single moment. Once we see it that way, it's almost impossible to unsee. The dinosaur world wasn't one golden age, it was many, rising, falling, transforming over 165 million years. And Tyrannosaurus Rex stood at the very edge of it all. Not at the beginning of the story, but just before the end. So, where exactly did T-Rex live? Well, not across the whole planet, not roaming every continent. Its world was surprisingly small. Around 66 million years ago, Western North America wasn't connected to the rest of the continent. A shallow sea ran straight down the middle, from the Arctic to the Gulf of Mexico, cutting the landmass in two. The western side was an island continent. Scientists call it Laramidia. This is where T-Rex lived, and as far as we know, nowhere else. Most of the fossils we found come from a stretch of rock called the Hell Creek Formation. It runs through Montana, North Dakota, South Dakota, and parts of Wyoming. When paleontologists dig there, they're not just finding T-Rex, they're finding an entire world preserved in stone. And that world looked nothing like ours. Picture a subtropical floodplain, rivers braiding through dense forests, swamps thick with humidity. The air is warm, heavy, and wet. Average temperatures sat around 11 to 12 degrees Celsius, higher than today, and rainfall was abundant. No grasslands. Grass hadn't really taken over yet. Instead, the ground was covered with ferns, and the forests were a mix of conifers and flowering trees. Palms grew alongside sycamores and magnolia. It was lush, it was humid, and it was crowded. This place was packed with life. Triceratops was everywhere. Those three-horned giants made up nearly 40% of the large animals in some fossil beds. Everywhere T-Rex looked, there were herds of them moving through the forest. Then there were the Hadrosaurs. Edmontosaurus, the duck-billed dinosaur, traveled in groups so large they probably shook the ground when they moved. Easy prey if you could catch one. And Kylosaurus was there too, low to the ground, armored like a tank, with a club on its tail that could shatter bone. Not an easy meal for anyone. Smaller dinosaurs darted through the underbrush. Pachycephalosaurus with its domed skull. Thescelosaurus, a modest plant eater that kept to itself. Raptors, oviraptorids, a whole community of creatures we rarely see in films because they weren't big enough to sell tickets. And beneath all of them, mammals. Tiny, furry, mostly nocturnal, scurrying through the leaf litter, staying out of sight. Their time would come, but not yet. In the rivers, crocodilians drifted. Turtles, fish, even sharks patrolled the waterways that connected to the inland sea. This was the Hell Creek ecosystem. Dense, diverse, fully functioning. And at the top of it all stood T-Rex. Not a rare sight either. Fossil surveys suggest T-Rexes made up nearly a quarter of large predator specimens in these deposits. That's a remarkable number. It tells us T-Rex wasn't some freak of nature glimpsed once in a generation. It was an established part of this world. Of all the T-Rex skeletons ever found, one stands above the rest. Her name is Sue. Discovered in South Dakota in 1990, Sue is approximately 90% complete, the most perfect T-Rex skeleton ever recovered. She now resides at the Field Museum in Chicago, where millions have stood beneath her reconstructed frame. But Sue's bones tell a harder story. Her skeleton shows evidence of healed injuries, bite wounds on her skull, broken ribs that mended, tail vertebrae that fused after trauma. She survived attacks, infections, and possibly gout. She lived a violent life, and her body kept score. When we look at Sue, we're not just seeing a skeleton, we're seeing the accumulated damage of a life spent at the top of the food chain. When we imagine T-Rex, we often picture it alone, cinematic, framed against an empty horizon. But that's not how it lived. It lived here, in this wet, green, noisy world, surrounded by prey, surrounded by competition, surrounded by life that had been evolving alongside it for millions of years. This was the kingdom it inherited, and it wouldn't last much longer. 66 million years later, we're still losing ecosystems, not to asteroids this time, but to ourselves. Throughout the world, we have these wetlands, but they're mostly concentrated across Europe. And here's what most people don't realize.